Hey, it's Mr. Saltano, and this video is going to explain how to convert from moles to volume and from volume back to moles. So the first thing you have to appreciate in order to do these problems is something called STP. STP stands for standard temperature and pressure. Now the standard temperature is represented as 0 degrees Celsius, so freezing point of water, or it is also represented as 273 Kelvin. Those are both the same temperature, just in different units. The standard pressure is referred to as 1 atmosphere, which is also often shown as 760 millimeters mercury, or 101.3 kilopascals. So all three of those units represent the same pressure, just different units, and this represents the same temperature, just in different units. I just remembered as 0 degrees Celsius and 1 atm because that's just easier for me to remember. Whatever works for you. You can always convert these temperatures or pressures later on as well. But the reason why this is important is because that temperature and that pressure taken together are considered standard temperature and pressure at certain conditions. Now, why that matters for the volume in 1 mole is because a gas under those standard conditions will occupy 22.4 liters of space. So that's volume, right? How much space you're taking up. So a gas under those conditions and under those conditions only will occupy this specific volume, so we can solve problems based on that assumption. So here you see helium 22.4 liters, chlorine 22.4 liters. These are all at STP. Here's a cube that has that 22.4 liters, and here's some of the dimensions of the cube. All of these, and contained in this balloon is 1 mole of gas, 1 mole of chlorine in this one. They all represent 1 mole of that gas. So 1 mole of gas under these conditions will occupy 22.4 liters. And there it is there as well. So something important to show here, if we look at these 3 balloons here, they're all representing different gases in those balloons. One has neon, one has oxygen, and one has carbon dioxide. If we look at the masses of these, they're all different. This has 20 grams, this has 32 grams, and that has 28 grams. Those are the molar masses of each of those chemicals. But notice that they're each under the same pressure, so they're each under 1 atmosphere. They're each under 273 Kelvin temperature. So what are we at then? Well, we're at STP. And so that means that each of these gases occupies an amount of space or volume of 22.4 liters. Even though they each have different masses, they're still going to occupy the same amount of space. And the reason is because there's 1 mole contained in each of those balloons. If it was any more or less than 1 mole, then it wouldn't occupy 22.4 liters. That's also an important note, is that if you have a higher or lower temperature, or you have a higher or lower pressure, you can't make that 22.4 liters assumption. It has to be at STP. So the problem will always say at STP, or you might have to use a different law called the ideal gas law, which is something, and that's for another lesson basically. So unless the problem says STP, you cannot use what we're about to use basically. Okay. And by the way, this is called molar volume, the volume taken up by 1 mole of a substance. Always a gas, basically, under STP conditions. So what volume? The question is, what volume will 0.75 moles of nitrogen gas occupy at STP? Okay, so now we can make this assumption. So the first thing we do, we're going to use dimensional analysis to solve this. First thing we do, we write down our given, which is 0.75 moles of nitrogen. And we know nitrogen's a diatomic, so it's N2. Okay. Then we're going to set up our fraction that we multiply by in order to solve these problems. And what units am I going to use on the bottom of the fraction? Well, I need my moles of nitrogen to go away because I want to have volume units, which are liters. So I'm going to go ahead and put 1 mole on bottom. Now remember, for our fraction, the top has to equal the bottom in some way. So we need some equivalent volume of 1 mole of nitrogen to put on top. And we can use this equality as our conversion factor because we know that under STP conditions, 1 mole will occupy 22.4 liters. So I'm going to go ahead and put that 22.4 liters on top. And now what we can do is we double check that we set it up correctly. Our units on top and bottom should cancel. And I'm going to extend the fraction over here. So then moles of N2 canceled with moles of N2. Okay, we did that correctly. Don't want to cancel the number though, so ignore that canceling of the number. The number's still there. And then I take my 0.75 times 22.4, and I'm going to go ahead and get the answer for that. And also, by the way, we're left in liters now, so that's what units we're going to be getting in the end. And so we have 16.8 liters. So in other words, 0.75 moles of nitrogen gas occupy 16.8 liters of space at STP. So let's try the other way then. Oh, and by the way, did it matter which gas it was? The answer is no. For these kind of problems where you're just converting to volume, it doesn't matter which gas you have, because 1 mole of the gas will occupy 22.4 liters at STP, regardless of the gas. So again, any gas, it didn't matter. Okay, so at STP, a gas, we're not going to bother saying which gas now, occupies a volume of 2.5 liters. How many moles of the gas are present? So start with our given, 2.5 liters. And then we go to do our conversion factor. Again, we put our fraction that we're going to multiply by. And what units are we putting on bottom? Well, we put our liters on bottom because we need to cancel that. And we know there's 22.4 liters of gas that are contained in 1 mole. So that's going to be our conversion factor again. Now we can go ahead and cancel our liters of gas with our liters of gas, and we're left with just mole units now, which is what we want. Now we take the top and divide by the bottom, and what we get is 0.116 moles of that gas. So that's how many moles of the gas are present. And that's really it for molar converting from moles to volume and volume to moles. Thanks for watching. Remember, chemistry is everywhere.